In the got it question, we have to decide for ourselves what kind of intervals that we want to use. We have finishing time in seconds for races. What is a histogram that could represent the data? So what we have to decide is what interval we think would be appropriate for a histogram. So we should probably find our smallest number. 80. I see that 80 is the minimum. Now we want to go through and we want to find the highest number. I see that 105 is the max. So when I think of 80 to 105, I know that's the difference between there is 25. So I'm thinking to myself that it would be good for us to either skip by 5s or for us to skip by 10s. Either one would be pretty acceptable. Why don't we skip by 10s and see what that looks like? See if that's a good enough chart for us. So we're going to get our axes ready. And what we need to do here is we need to show that we're going to skip by some amounts. And if you remember back from middle school, you have to use like a little skip here. And that will show that you're skipping a significant amount before what we need to get to. Now if I skip by 10s, that means I'm going to do from 80 to 89, from 90 to 99, and from 100 to 109. Alright, so I'm going to break this off, and I can stop at 109 because I'm past my highest. I'm going to break this off into about 3 appropriate sections, so maybe 1, you want them to be the same width, 2, and 3. That looks pretty good. Pretty good widths there. Now this particular will be 80 to 89. This will be 90 to 99. And this will be 100 to 109. And this we need to label as time in seconds. Going up will always be the frequency. So let's go ahead and figure out how many times does 80 to 89 happen. 80 to 89. 1, 2, 3, 4, 5, 6 times. So I'm gonna go ahead and count them all first. 80 to 89 happens 6 times. Now we need to do 90 to 99. 1, 2, 3, 4, 5. And last, we're going to do 100 to 109. 1, 2, and that's it. Now what I'm going to do is I'm going to break this up. It has to go up to at least 6, so I'm going to break it up as evenly as possible. 1, 2, 3, 4, 5, and 6 is the highest I need to go. And let's just make our chart from there. Keep them as straight as you can. This one's going to go all the way up to 6. Now 90 to 99. That's going to go up to 5. And last, 100 to 109 is only going to go up to 2. So I'm going to eye this up like this. And there you go. You have a nice histogram. But look, we do have room for a title on this one. This is the finishing times. There you go. Now histograms can have like a label to them. And if we study down here, we can take a look at the 3 different types of histograms we may have. The first one is if the bars are roughly about the same height. If they are about the same height, we call that uniform because they're pretty well spread out in the intervals. The next one, if you can have like a vertical line that divides it into two parts that are close to a mirror image, meaning this. Can you see that if I like draw a vertical line, how it's pretty much the same over here as it is over here? That means that it's what we call symmetric. And that would mean your average is right around the middle. And then the last one is when they tend to go up, but the peak is not quite in the middle. And like, let's underline that. The peak is not in the center. The peak could be to the left, to the right. That's called skewed. Now let's look at problem 3 and try to label what we think these ones are. Look at problem 3A. Would you label it as uniform, symmetric, or skewed? Put your answer down. Hopefully you wrote down that you want it to be symmetric. And the reason it's symmetric is because I could put a vertical line and you can see that it almost splits it in half. Okay, mirror images. Let's look at problem 3B. What do you think about this particular graph? They're not uniform because they don't go straight across, and they're also not symmetric because it's not like I can draw a vertical line and separate it. This would be what we call skewed. And it's actually skewed to the right. That's because the peak is not in the middle. Continuing on, in the got it, it says the following set of data shows the numbers of dollars Jay spent on lunch over the last 2 weeks. Make a histogram of the data. Is the histogram uniform, symmetric, or skewed? Alright, well let's go ahead and take a look at the different items that we have. I see that my smallest is a 1, and I see that my highest goes all the way up to 17. I would say that from 1 to 17, a good interval to skip by would be by 5s. 10s wouldn't give us much of an interval at all. So let's make our histogram. Give it room for a title. And that will be 1 to 5, 6 to 10, 11 to 15, and 16 to 20. How many times does 1 to 5 happen? 1, 2, 3, 4 times. How many times does 6 to 10 happen? 1, 2, 3, 4. How many times does 11 to 15 happen? 1, 2, 3, 4. And how many times does 16 to 20 happen? 1, 2. Okay, so let's go ahead and break this up. We're going to have 4 different categories. All right. Now the highest frequency I need is also a 4. Let's put our labels on. And let's also put our intervals on. So this would be, and I should show that I'm skipping just a little bit. So we're going to start that bar there. I want to make these just a little more uniform if that's where I'm going to start the bar. Okay, so I skipped just a little bit to show that I'm actually going from 1 to 5, 6 to 10, 11 to 15, and 16 to 20. Up 1, 2, 3, 4. Pause the video if I'm going too fast to catch up. Alright, now these ones happen 4 times. And you should notice that that happens for the first 3 intervals. So I'm going to cheat a little bit here. And I'm just going to do all 4 at once and then break them up in a second. all 4 of these are going to be the exact same height. Or excuse me, all 3 of these intervals are going to be the exact same height. They are all 4 tall. Now the 16 through 20 is only 2 tall. So I'm going to get my ruler. And you want these to look really nice. Sloppiness is not acceptable on histograms. One's only 2 tall. You can color them in if you want. And there you have your histogram. All we need now is a title. And this would be $, spent on lunch. Okay, so the question is, would you consider this uniform, skewed, or symmetric? I would consider this one pretty uniform. Yeah, this one's a little bit off kilter, but in general, they're all right around $4. So we're going to call this one uniform. Again, uniform doesn't mean that it's perfect. It means what does it tend to look like. Let's look at the bottom thing here. A cumulative frequency table shows the number of data values that lie in or below a given interval. For example, the cumulative frequency for the interval 70 to 79 is 20, then there are 20 data values less than or equal to 79. Problem 4. Making a cumulative frequency table. Text messaging. The number of text messages sent on one day by different students are shown below. What is a cumulative frequency table that represents the data? So let's look at this and how it's different. What I'm covering up, if you just look at what I'm not covering up, that's a frequency table. When I add the cumulative frequency, that makes it a cumulative frequency table. Let me teach you how this works. I want you to count how many times 0 to 9 happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I see that 0 to 9 happened 11 times. So far, the cumulative frequency is 11 because that's as far or as many as we've had so far. Now 10 to 19. 1, 2, 3. I see 3. Now the cumulative frequency is what the cumulative frequency was before plus what we have now, so it's 14. And that came from 11 plus 3. It's like, hey, how many have you counted so far? All right, 20 to 29. 1, 2, 3. The cumulative frequency will be what we used to have plus our additional 3, so 17. So that came from 14 plus 3. In other words, how many have you counted so far? 30 to 39. 1, 2. Happens twice. So far we've counted 19 items. That came from 17 plus 2. And then last, 40 to 49 happens 2 times. So we do 19 and 2 makes 21. Again, that's how many did you count so far. So this is called a cumulative frequency table. Now if you want to do the got it, you can, but it's going to be the exact same thing. It shouldn't take us too long, so we may as well. Problem 4. I see that my smallest is 0, and let's take a look for the biggest one. I see that my biggest is 15. I would say for this particular item, we could probably count by 4s. If we counted by 5s, we'd only have like 3 sets. So I'm going to count by 4s instead. And I'm going to put my frequency table over here. So we'll do, excuse me, we will count by 5s. I'm sorry. Let's count by 5s instead. Because that will, since we include 0, we'll have more than just a few of things. So let's count by 5s. So we'll do 0 to 4. We'll do 5 to 9. we'll do 10, 10 to 14, 15 to 19. Okay, how many times does 0 to 4 happen? Count them up. You should get that 0 to 4 happens 6 times. So far, our cumulative frequency is 6. 5 to 9, please count them up. For 5 to 9, you should have got that happened 4 times. Okay? 10 to 14. You should get that happened 4 times. And 15 through 19. That should be the remaining 2. Now you notice I saved the cumulative frequency until the end. That's fine. For 5 to 9, the cumulative frequency would be 6 plus 4, or 10. For 10 to 14, it would be 10 plus 4, or 14. And for 15 to 19, it would be 14 plus 2, or 6. Excuse me, 16. So go ahead, look things over. Make sure you understand the difference between a frequency table, a histogram, and a cumulative frequency table.